Hey everybody, welcome back. This is Tech Junior Tutorials. I'm Lee Warwick Jr. and we're doing Advent of Code. Advent of Code is one coding puzzle every day until Christmas at adventofcode.com. So today is day 11, Space Police. This was a super fun one, in my opinion. So let's check it out. So it says, on your way to Jupiter, we're getting pulled over by some space cops, and they say, hey, you don't have basically a space license plate, and if you don't get one or register or whatever, you're going to space jail. So today's problem is going to run on the Intcode program from days, what is it, 2, 5, 7, 9, and today. Seems like almost every other day we're going back to Intcode. Luckily, we didn't have to add any features or anything to Intcode, but today we're going to be using the inputs and outputs. So we're getting an input that is an Intcode program, and we have to kind of construct the INO for that. So what it says is that we're going to build a hull painting robot. So basically, we're going to be on some kind of grid again. And all the grid is by default black. I guess we're flying a black spaceship. So the robot is going to be facing upwards when we start, and then it's going to move in a direction, and then decide whether or not to paint whatever it was on, white or black. So I guess here it was black, and then it moved a couple more spaces and then painted white, and is now facing up again. So if we started here, maybe we moved here, here, paint white, maybe come here and then come here and paint and then paint. So the rules they tell you for this are that you're going to get two outputs from Intcode, and the first one is going to be what color to paint. So if you get a 0, you're supposed to paint black, and a 1 means paint white. And then the second is another 0 or 1, and it's going to tell you whether to turn left or turn right. And then it says after each turn, you're going to move forward one panel in whatever direction you're facing. So they say like, so if we were here and we got a 0, 0, that would tell us paint it black and then turn left, which would be down, and then move forward, which is why we end up facing downwards. So, excuse me. So, the other thing is the input, and the input is the robot supposedly has a camera on it, so it's going to look directly underneath it, which is covered up right here. But they're saying, like, pretend that this was a white square. So it's going to receive an instruction that says, like, hey, what color am I sitting over? And then after that, it's going to say whether or not to change the color and then turn a direction and move. So that's the one input and the two outputs that you're going to get for each set of instructions. And then it gives you the challenge, which is count how many panels that you've actually painted at least once. So if you move over a panel and you paint it, that counts. If you move back over it and paint it again, it still only counts as one panel. And then at the very bottom, they give you your puzzle input, which is, again, just a big, long, comma-separated value of Intcode programs. So for today's, basically, jumping into the code, I just copied over my Intcode program from day 7, I believe, which was, or no, day 9, I think was the complete one. So that's when we actually add in the relative base stuff. So check out that video if you are concerned about that. And then days 2 and 5 and 7, no, 2, 5, and 9. I think 7 was also using Intcode, but it kind of didn't really have too much to do with changing the actual Intcode program itself. But for today's, I copied over that existing Intcode code, and then I decided, okay, if I'm going to make a robot, from the beginning of this, I've been doing everything like functionally or just using global variables. But this thing has like a lot of commands and stuff, so I decided like I'm going to take a crack at writing a class in Python, which I don't use a whole lot of in JavaScript, to be honest with you. So doing that, I started with a paint robot class, and I said like, okay, here's my variables starting out. I'm going to be at position 0, 0. I'm going to be facing up. And then instead of like trying to figure out a grid that I'm on and like maintaining this grid and the size of it and stuff, like I pretended that I'm not going to track a grid. I'm going to track like where all the points are that I've been. So I'm going to start at 0, 0, and then whatever they tell me to do, turn left. I'm just going to store whatever point I land on, and then store that as a set so that the set is only going to contain, actually this is a dictionary that I'm using. So the dictionary is only going to contain unique keys. So I store the key as a string of the input or the position. So if I move over a position again, I'll just update the current paint value, and then it won't matter at the end. I'll just have the total number of painted panels without repeats, basically. So aside from that, I made a bunch of helper functions or methods in this class. So I've got like printing the panel count. That's just very easy. Prints the length of the painted panels. I print my current position. Print a picture was more for part 2, so we'll get back to that. Get panel color ended up being my input for the encode program. So what that does is it looks at my current position, and then it turns that into a string, like how I'm storing all my positions. And that just says, hey, if the panel is in there, in that dictionary of panels, go ahead and grab whatever color that is. Otherwise, like, it's probably a black panel because I haven't painted it before. I've got a little helper function to go ahead and give me the XY value as integers and a list or a tuple instead of as a string. And then my receive input function is what I'm going to be getting out of encode. So it's going to receive sets of 2 instructions. So the first one is the paint, and then the second one is the direction to turn. So I start out with painting true. I just keep track of like an internal Boolean for this and say like, when I get an instruction, I know that I'm going to be painting because that's always the first one. So go ahead and run a function to paint and then switch painting to false. And then that will say that the next time I get an input into my robot, I'm going to know that I'm going to be moving and not painting. And it just flips back and forth. So my paint function is super simple. I just grab my current position and save it with whatever color they gave, which was a 0 or a 1. And then for the move, this is where things fell apart for me today. So this is the correct code now. But what was happening was I was running my code, and basically my robot was spinning in circles. It would turn up and then left, and then up and then left, and then up and then left. And I couldn't figure out what was going on. Python doesn't have switch statements. It has like some kind of hash map workaround kind of thing for that. But I don't want to get into that right now, being kind of inexperienced with Python. So I figured like, heck with that. I just want to get this done. Let me use if, else, if, because that's pretty much the same thing as using a switch in like JavaScript or a different language. And so I did that, but what I ended up doing first was this. So when I first wrote this, I just wrote if statements, and I did that for these down here as well. But what this says is like, okay, if I'm up, turn left or right, which is correct. If I get a 1, that means turn left. Or I'm sorry, if I get a 0, that means turn left, and then a 1 means turn right. So if I'm facing up, that is left and right. And that's correct. All these are correct. But what happened was when you run this, so you become, like, you start up, but then it gives you the direction to turn. So you're like, okay, the first one is, let's say, a left. And so you turn left, and then it goes, oh, hey, you are facing left. And then it turns down, and then down comes down here, and then it turns left again. And so, like, all 4 of these ran every time that I got a direction, and the same thing with these. So, like, I turned, like, 2 or 3 times, and then I moved. I think this was okay. It was 1 time, but I really wanted to fix this by making these exclusive. So that's what it should be. This says, like, only match one of these things at a time and then move on, as opposed to, like, match each thing and then do something. So Once I fixed that, it was just a matter of like figuring out the direction. So if you're facing up and you move forward, if I'm counting the top left as 0, 0, then moving upward would be a negative y move. So I just subtract 1 from y. And then this is like mathy calculus way of saying like the change in y and the change in x. So moving up goes negative 1y, moving down goes positive 1y, and then left and right for x. Right is 1, left is negative 1. So super simple code. That's actually all I had to add. So just this class with these couple of methods on it. And so when you run this, so it runs for a second, and then it counts the number of panels that I painted, which is a ton. And then it gives you a current position, which means I ended up 45 places to the left of 0, 0, and 32 places above 0, 0 after I was done painting. So I was a little concerned about part 2 because if you look at part 2, they're like, okay, that's great, but we don't really know what it's painting. They say like it painted some nonsense value, and so they say check it again, and hey, you're not supposed to start on a black panel, you're actually supposed to start on a white panel, and then that will paint the correct thing. So you're supposed to just swap that and then see what it paints. So to do that in my code, the only thing that I had to change was up here at the very top of this class. I just flipped this empty set into a, hey, you're starting on 0, 0, and that is white. So that's great. That stores all the correct panels and the color, but then I need to render that to actually be able to read it as a human. So to do that, I had to do another method, which is this print picture method. And so for that, I kind of need to know how big this grid is, because if it's a smaller grid at first and I try and print all these values, then I could be in trouble because I could have like negative values. Like what if the robot, like we saw in the beginning, ends up above and to the left of the origin? So I was kind of like, oh man, am I going to have to do some fancy math to check like the min and max values? But when I looked at my puzzle input, I actually printed all of the painted panels dictionary, and they all looked positive. So I was like, okay, I'm just going to try this and see if it works. And if you do that and you just check like basically loop over the points and find the greatest x and the greatest y value, and then make a grid that is that size of nested or 2D lists, basically like the outside list is y, and that has a bunch of lists for the x values. So again, just like the previous thing where we were printing like asteroids in a grid, this is printing squares that are black or white. So I went ahead and did that, and then looped over it and painted them, and I ended up with like a bunch of zeros and ones, and it was really hard to read. So what I did was I said, I'm going to make the panels all periods, and I'm going to say, once I loop over them, I'm going to say if the paint is a 1, go ahead and do a hashtag, and then if it's a 0, do a dot. So like white panels will show up much easier against the dots. And then somebody challenged me to do an animation of the printing. So I used the code from yesterday, which this basically clears the console if you're on Mac or Windows. Or I'm sorry, Linux or Mac, or like a Linux Unix-based system or a Windows. And so to print, I just say like every time I get a value, go ahead and call print painting again, which is an internal method or internal function inside this method. And what that does is just loop over that 2D grid, and it says for each row, go ahead and convert it, each number, to a string, and then print all the values joined together with a space between them. So it makes a lot more sense whenever you watch this when I do it. So let's go ahead and try that real quick. And then down at the bottom, I just called that internal method to print the picture. So if we do this again, So let's clear this and give it a little more space, and hopefully it doesn't blow up because I forgot something. There we go, it's printing. So pretty cool, right? It does like a little animation where it goes from right to left and back right and then back left. So I didn't try and make it follow that order or anything. I remember I'm using a dictionary for all the stored points, so it's doing its own internal sorting of that list of keys, if Python does that, that generates that pattern. So watching it again, like it's actually going up and down for the first 2 rows, and then kind of like almost like a printer, which is crazy. So I don't know if Python stores those values in the order that you add them, and that's just like happens to be the path of the robot. But that, I don't know, I just thought that was really cool. So I watched that about 100 times. But yeah, so you can read with the dots and the hashtags, it's really easy to see what the letters are for that. So JZPJRAGJ. And if you look at the problem, that's what I typed in, and that was the answer. So that was really cool. I really enjoyed day 11. Felt like it was enough of a challenge without being like overly hard, and it was a good excuse to get a little deeper into Python and learn about classes and how to write methods and stuff, which was awesome. So really enjoyed that. Looking forward to tomorrow. Hopefully it's doable. As we get closer to Christmas, like everything gets busier for a lot of people and their families and stuff, so hope to have enough time to keep doing these. But yeah, that's all I've got for today. Let me know how you're doing with these in the comments. Like, subscribe, follow, all that good stuff. Hit me up on Twitter, @LeeWarwick Jr., and let me know how you're doing with that event of code. And I will see you tomorrow. Bye.